Yeah. So hello everyone. So we'll be starting with the question number 38. That is count and say. I just saw that this question having so many dislikes, but when I just did the question, so I just found it very useful. So let's start with the question. So basically, what is the question is? First, I'll read the question. The count and say sequence is a sequence of digit strings defined by the recursion formula. So count and say of 1 is equals to 1, we have given it, and count of say of n is the way you would say the digit string from count and say of n minus 1, okay, which is then converted into different digit string. So, to determine how you say a digit string, split it into the minimal number of substrings such that each substring contains exactly one unique digit. Then, for each substring, say the number of digits, then say the digit. Finally, concatenate every set digits. Okay. So just when when I just read this question, I was like, what? So when you will see count and say, you will definitely get the answer. So we'll take this 332251. So see, two digit consecutive digits, we have two threes, we have two threes, then three consecutive two, we have three twos, and one five and one one. So what we have written is 2 3. Yeah, it means 2 is the count of 3, 3 is the count of 2, and 1 is the count of 5, and 1 is the count of 1. So we have this string 2 3 3 2 1 5 1 1. So this is something count. We have to count the digit of the count the digit, and we have to write the counts. So this is the question basically. So will I'll explain the test cases. We'll take second one. See, n equals to 1 we already have, so this is a base case. When n equals to 1, we'll return the 1. So we'll take n equals to 4, how we can solve it. So suppose we have n equals to 4. Okay. So how we can solve it using the recursion formula. So suppose we have a function f. We have given f equals to 1, 1, right? So what will be the 2? 2 can be, see, how many digit of 1 we have? 1. Wait for this. Uh, So 1 and 1. What is this? The count of 1 is 1 and the digit is 1. So then f of 3 will be, oh god, f of 3 will be, we have two consecutive ones. So 2 is the count of 1 and digit is 1, right? So f of 4 can be, number of count of 2 we have is 1, right? And number of count of 1 we have is 1. So 1 2 1 1 can be the answer. So what we have, 1 2 1 1. So now the what can be the approach? So after we can see, we can do simply by recursion. So something like 1 is returning to 2 is 1 1, then 2 will return to 3 is 2 1, then 3 will return to 4 is 1 2 1 1, right? So this is a simply based on recursion, so we can solve it. Okay, so I'll just show the code. I have written it. It will be the same what I just explained you right here. Okay. Okay, so yeah, we have this. So the code says, see, what we are doing in the first few lines is only the recursion. So suppose we have n equals to 4. So what we can do is 4 will call to 3, then 3 to 1, 3 to 2, then 2 to 1. So 1 will return simply the answer 1, right? Then we'll calculate for the 2. 2 will return to 3. What it will return is 2 1. Then it will return to 4 is 1 to 1 1. And this if condition is saying the, we are just calculating the consecutive digits and the count. When we'll get the consecutive digit, we will simply plus the count of that digit and that particular digit. Okay, and we'll just iterate it, and when the digit is single, count like one, two one. So what the count for the two is one simply. So in else condition we will just plus the simple count and that particular digit. So this is the simple problem of the based on the recursion. So it just like I just saw the dislike, so I just thought of explaining it. So if anybody having any question, just do comment. We will definitely solve the queries. Yeah. So thank you.